This is the overview for what is it? Module 2, differentiation skills. Okay, so don't start this booklet until you've hopefully mastered the polynomials here and this huge one, this one here, composite functions or the chain rule. You need the chain rule to progress. Okay, very quickly, the overview here. Yeah, this front page, there's the formula sheet. In fact, if we open up that formula sheet, it'll take you to here, and you will basically learn all about this table in here. And the next page, the product rule, and the second one here, the quotient rule, are going to be covered in this workbooklet. Okay, so just a wee heads up, the types of expressions here. You're probably used to y equals. Looks like lots of people are, whereas no one's going to this person here, function of x. Hey, we had a quick look at a worksheet here. Well, this is from New Lake. This is the stuff you'll be doing very soon. Hey, look, we see y equals. We see y equals. Here we see h equals. Does it matter? No. So just hope you're not stressed by how the function or the thing you're interested in, the thing you're going to differentiate most likely, is presented, and hope you can cope with y or h or g, or most common is the f of x, f standing for function, in terms, the vertical function in terms of the resulting x value, the curve it follows. Okay, so this module, you're going to look at exponentials. Okay, this bit here, log curves, in particular natural logs, not log base 2, log base 10. It has to be natural logs. Righty, and trig functions. You need to recap reciprocal trig functions. Sec, cosec, cot, what are they? You'll learn that there, and how to deal with differentiating expressions that are trig related. So for example, y equals 2 sine x. Differentiate that. What does it equal? The product rule is huge. You'll need to know this. Once you understand the rule and practice it heaps, you'll get the confidence. Hopefully you'll be like this guy here. Can you be chill vibe? Can you be able to apply the product rule and get a nice, elegant solution like this? The quotient rule is up there with the product rule. The coding here. And again, practice, practice, practice. As it says here, the New Lake practices are good. Hey, I just showed you these pages here. This is the tough stuff. This is quotient rule. You can see a fraction here. How do you differentiate these? If you know the quotient rule, it's not too bad. You will generate screes of paper, but if you set the working out, if you follow my examples, they are good. Okay, you should be able to work it through. Hey, just a note, at the bottom of some of these sections, I've got extra, and this lady here features a bit, Nancy Pye. She's pretty good. Another guy, Professor Dave. People that I think show the concepts reasonably well. And obviously, my go-to actually is, for example, this one here. Okay, there down the bottom, infinity plus 1. Really good examples. He says it so well, and hopefully by watching his videos, you'll get the confidence. Don't forget other learning options for all these aspects here. STEM Online has some really good stuff. Look at their logic, their flow of how they explain the concepts, their links, and in particular their opportunities for you to practice. And I think that drag and drop multiple choice and whatever websites they suggest you go to, that's good practice. So folks, there's a fair bit of time and energy going to be, probably 2 or 3 sessions, VC sessions. Definitely 2 or 3 hours on quotient rule, 2 or 3 hours on the product rule, and these guys here to get your heads in a good space. Hey, very quickly to the bottom bit here, it's module 2. In fact, the title here said achieved and merit level. Some of the quotient product rule stuff is low-end merit, but it's all solid achieved merit skills, okay? The next booklet, by the way, Curve Features, is using the product quotient rule skills in context, and that is solid merit. So to do well in this next module work booklet, you need your product rule, your quotient rule, and not scared by exponentials or trig functions or log curves. Okay, so the module review, I've just basically this is for Mr. Chander again, and yeah, sort of the breakdown. Lots of exponential log, product, and quotient problems. So it's a bit of a potpourri, a mixture. Have a go. Some of these videos, you pause it, look at them on the screen, have a go, paper in front of you, unpause, and hopefully what you have written appears in front of you on the video screen. Really good self-based learning. Okay, this one here from this American guy who's giving us um, these graphics here, quite funny. Yeah, chain rule, some good stuff in there, lots of good problems and so forth. If you really want to test your mettle, go look at these pages, 115 and 116. Let's just go here. Okay, so this is the end, sort of a chapter review in New Lake, and again, some good examples there, and all of page 115. There's some really interesting stuff in there, and it's a good cross section of all the work you've covered. Now it's not going to load, but trust me, by doing those ones there, if you can do, if New Lake says their merit, we won't argue. Let's assume their merit level. But if you want to actually see exam-based questions, I put here the word achieved. Here is a document you can click. I'm assuming everyone can look at it. Yep, anyone can. And basically what I've done here is I've done these years and I've taken out the skills, the questions. So for example, let's say you chose 2017. In theory, after you've done this module, you could do question 1A. You could do basically, actually question 1B, you actually you need the next booklet, but you could do that one there, you could do that one there, you could do that one there, that one there, that one there. Actually, this one here is more kinematics. Okay, but for example, these skill sets you should be able to have a good go at and make some sense of them. All good. I hope it goes well, and do the Mahi team, and you'll get the results there.